Now, having discussed the Bernoulli equation, we will discuss about the Reynolds transport theorem, which is the very important theorem in fluid mechanics, because this is the theorem which relates system property to the control volume property, because in many engineering situations we assume control volume and we write the equation for that control volume and solve that equation to get the answer to different questions, right. So, what is the relationship between system property and control volume property? That is related with the help of Reynolds transport theorem. And why there is need to develop relationship between system property and the control volume property? It is because the Newton's second law of motion is applicable to point, basically rate of change of momentum is equal to force at a point. So, that law is developed for a point, though it is applied to certain other bodies where mass is distributed, but mass is assumed to be concentrated at the center of gravity of that body, and then Newton's second law of motion is applied. But in case of the fluid mechanics, we sometime need to consider a control volume where mass can go inside the control volume and mass can go out the control volume. So, in this case, how can we relate system property to control volume property, so that we can write the Newton's second law and we can solve that equation for getting the answer to certain questions, right. So, to understand Reynolds transport theorem, we have a pipe having variable area, or we have a diverging pipe. In this diverging pipe, we have selected this control volume from this point to this point, right, where velocity through which fluid is entering in this control volume is V1 and through which it is going outside is V2. Now, in this figure we have shown another control volume, this one, between this section and this section. Our aim is to develop relationship between control volume and control mass or system. What is the difference between control volume and control mass? In control mass, the mass remain fixed. It may change the position, but its value and its nature will remain same. But in control volume, mass can go inside the control volume and mass can go outside the control volume. This is the difference between control volume and control mass. Now, in control volume, once we define a control volume in a given space, then its boundary also remain fixed over the time. As such, by virtue of the definition of the control mass, that control mass may shift, because in control mass our intention is to focus on those particular molecules where their nature remain fixed. So, if you look at this figure, this is the definition of the control volume which we have defined here between these two sections, this control volume. So, over the time this space will remain fixed. Now, whatever molecules were here at some time t, at time t plus delta t, those molecules which were inside this control volume, they have gone to this area which is enclosed between these two sections. So, these molecules or this mass of the fluid, this was inside the control volume, it has come out and it has taken this position in this figure between this section and this section at time t plus delta t. So, at time t we have a control volume between these two and we have a control mass also between these two, but at time t plus delta t the control volume remains same, but control mass between this point and this point. So, it means that what is the change in properties? Now, if we want to relate this control volume to control mass, in that case what happens, at time t the system property and control volume both were same. At time t these all were same. At time t plus delta t, at time t plus delta t, this is the system shown with the help of these section lines at these 45 degree, is equal to control volume. This is the control volume between these two lines, control volume minus this area and plus this area, right, because basically at time t system and control volume both were same. At time t plus delta t the system, this is the system, right, this is the system and this one is the control volume between 1 and 2. So, out of control volume if we make minus 1, then this much is left and plus this 2. So, this in this way we can relate system property to the control volume property. At time t the system property and control volume property both are same. At time t plus delta t the system, which is this one, is equal to control volume, which is this one. So, out of control volume if we want to relate this term, then we have to subtract this portion of control volume minus 1 and we have to add this portion, we will reach to this position, right. So, after understanding this figure we can write equation for property.